So in this video, we're going to be solving using law of cosines to find missing sides and missing angles. It's just like law of sines, but different. So here's our formulas. You have a squared equals b squared plus c squared minus, and it's this all. And they look very daunting, but it's really not. If you look, you just basically have a sandwich or an Oreo cookie where the outsides are a's or b's or c's. The letters just go together. So the way I always like to think of it is just like Pythagorean theorem. So we would say c squared equals a squared plus b squared. And then we have a cosine sandwich. So c on the inside, c on the outside. So you just start with the angle. Whatever angle they gave you, that goes here, and you put the little c on the other side. And then it's the other two letters, so a squared plus b squared. And then it's two ABs here because you have an A and a B, so there's two ABs. Just a kind of quick way to remember it. So it doesn't really matter what letter it is. This could be B, and so you'd put B squared over here. And so the other two letters are A squared and C squared, and so you'd put minus 2AC. And so if it was A, you would then say A squared equals, and so the other letters you're missing are B squared and C squared, minus 2BC. So that's it. It's just the angle. That's where you want to focus on, what angle you have first. So since we're given C, that's the one we're using, and then you plug everything in. So we're looking for C, so then we would have 7 squared plus 5 squared minus 2 times 7 times 5 cosine of 83. And we plug this in exactly how it looks into our calculator. So 7 squared plus 5 squared minus this. So 7 squared plus 5 squared, the two sides, minus, and then it's 2 again, times 7, times 5. And then it's cosine, make sure it's in degrees, and then the angle 83. And then you hit enter. And so there it is, so 65.47. So c squared equals 65.47. And then we square root, and we're only looking for the positive here because we have a side length here, you can't have negative side lengths. So now we just need to square root it. So second square root, go back up and grab it, and then hit enter, and it says we'll just say 8.1 to round it off. So 8.09 or 8.1. So it equals 8.1. So that's it. That's pretty much law of cosines. We're going to go through each one and be able to plug in and say find a c given this formula, or find that angle, and everything else. I'll give you every single situation you'll run into. But that is law of cosines. So hopefully you got the formula figured out. Okay, so there we go. See, 8.1. So you can see this is basically what it is here. You have an angle, and then it's included between the two sides, and that gives us the final one we're looking for. So it says 8.1. So you can use the formula to find that missing side over and over and over again, given any side length that you have. So what it's using is the two sides and the included angle. These are just random letters that are plugged in. So if we had 20.2, 8.5 with an included angle of 92, then C is this. So it's a nice quick formula. Some things to remember. Remember, if C is positive, right? Our cosine here is positive if it's less than 90, and if we go over 90, our cosine would turn out to be negative, and that's why this right here, if this cosine of 127, if you plug that in your calculator, you'll see it's negative, which would turn this positive, which means we're now adding, and that's why our C is getting so big. So bigger angle, see the C gets bigger as we go. So things to remember. So again, if it's less than 90, this cosine would be positive. And if it's more than 90, our cosine is going to turn negative, which turns that positive. Okay, let's look at some more now. So in this one, we're given 3 different sides. So since we have 3 sides, this is where law of cosines comes in handy, and law of sines is not going to work for us. So since we're looking for angle B, that's where you always want to start. That's cosine B. So then we have our B sandwich. So the other two letters are A and C. And so we do 2 of them as well, just like that. So now all we have to do is plug it in and solve for cosine B. So what I'm going to do is erase cosine B and put it in red, because that's what we need to solve for, that entire cosine. And then at the end, we can do an inverse cosine on it to find angle B. So let's plug it in. That's 7 squared. That's 4 squared. That's 5 squared minus 2 times 4 times 5. Write it in red. cosine B. All right, so we can't just add these across like we did before. So 49 equals 16 plus 25 minus 8 times 5 is 40. And then cosine B. And so this is 49 equals, and that would be 41. Okay, so you don't want to subtract these. That's a common error, is to subtract these. This 40 is attached to cosine B. It's quantity. So you're going to subtract, divide, just like you would do a normal equation. So minus 41, minus 41. So that's 8. And then divide. So 8 over negative 40 equals cosine B. And we don't need to simplify that because we're going to be plugging it in the calculator anyways. So this is becoming, our B then would be the inverse cosine of negative 8 over 40. And since we're dealing with a negative, we know our angle is obtuse for cosine. So if you were to draw the triangle right now, we're looking for angle B. I like to put the obtuse up there. It will give it to us. And then we put our side lengths on. So this B would be 7. See, it's the biggest of all of them. And then we'd have 5 and 4. So 5 is opposite, would be capital C. And 4 is capital A. And so now we have our triangle. So that's going to give us this angle. So let's plug in our calculator and see what we get. So that gives us 101, see? 101.5. So our angle B is 101.5 degrees. So we know that's 101.5. So now you could use law of sines to find the other ones, but I want you to practice law of cosine since we're doing this. So obviously we could use to find C, you would just use B in its side and C in its side to find it. And then look and see if it's ambiguous. But we're going to use law of cosines to find this. Okay, so I want you to find angle C using these values. Well, there's no ambiguous because all the sides are given. So go back and use law of cosines. Hit pause now. So this is what you should have gotten. So since we're looking for angle C, you put cosine C, and then C squared, so A squared B squared 2AB. And then we solve it the same way. We add these together, subtract it to give us this, and divide it. And you see now this one's positive. So since it's positive, that means we're going to get a less than 90 angle. You remember a cosine is positive in quadrant 1 and it's negative in quadrant 2. So if it's negative, our cosine's negative, then we know we're going to have an angle in quadrant 2. And if our cosine's positive, we know we're going to have an angle in quadrant 1. And so we get that. And so then you can use 180 degrees to find angle A, or you could do this all over again for angle A, or you could use law of sines, but it's the same idea. And again, the reason we don't have any ambiguous cases to worry about is all three sides are given. So if we lock it down with a side, 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 we know we only have one triangle. That is the definition. Remember, for congruent triangles, if you have side, 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 you're done. So there you go. There's how you find an angle. So there's how you find the side. There's how you find the angle. And then we've got to do one ambiguous case. So this will happen. So with ambiguous cases in law of cosines, where it happens is we end up with quadratic formula. So it's not with the angles, it's with finding one of the sides. So we have our triangle here. So remember, this is when we get our ambiguous cases and we're giving an angle and an opposite side and then the side, and we're trying to find that matching angle, see? So what happens is with that angle and the given side, when they are larger, we get one triangle. But as soon as that opposite side of the given angle is smaller, then remember we get this situation where this one is small, and so it could connect here or here. Remember, if you do that little swoop here, you're getting two different triangles. Then again, it could also get too small and then you don't have any. But if it's smaller, we're going to get 2. And so how does that occur with law of cosines? Let's find out. So here we go. So if you look, we have an angle B and B. And so let's look at that picture just to show you what I'm talking about here. And so if this is B, this would be 5, and that's 40. And then we can call this one C, and so that would be 6. So you can see that that 5 is smaller than 6, which means this is possible as well. We could have a 5 here or a 5 here. It's small enough. If this one gets bigger, then our line comes outside. It's not going to work. So we should get 2 answers here where we have an ambiguous situation going on. So let's see how that works with law of cosines. So again, we're starting with B. So we have angle B, so we know that. And so we're doing a B sandwich. So the other letters are A squared and C squared. And then we get 2 of them in the middle, right? And so there's our formula. So let's plug what we have in. So 5 squared equals A squared plus 6 squared minus 2A times 6 cosine of 40. So you can see how we have the A squared and the A. This is where the quadratic happens, and you're going to get that plus or minus, which is where we get our 2 sides here. Okay, so we get 25 equals A squared plus 36 minus, and then this last one, you just want to plug that in your calculator. So 2 times 6 times cosine 40. So 2 times 6 times cosine 40 gives us 9.19a. And so now it's just using quadratic. So we move the 25 over, and we put it in descending order. So a squared minus 9.19a plus 11. All right? And so a equals negative b, so negative 9.19, plus or minus, we're the square balancer. Remove 4 alcoholic cans, and it was all over at 2 a.m. So it's negative b plus or minus the square root of b squared minus 4ac all over 2a. So it's a negative boy, couldn't decide whether the square bouncer. Remove 4 alcoholic cans, and it was all over at 2 a.m. All right, so let's see what we get here. So this is a 9.19 plus or minus, and then that square root, we're just going to plug in the calculator. Our a here is 1, so we get this. So let's plug this in our calculator and see what we get. So we end up with this. I've done the 2 times 6 cosine 40 to get the 9.19 and then square it that way. Minus 4 times, I didn't put in the 1, times 11. And we get 6.364. 6.364. And so these are our 2 answers. So we're going to do 9.19 plus 6.364 and then divide it by 2. And we're going to do 9.19 minus 6.364. So this is where our 2 answers occur. So we're going to get that one and that one. So let's plug them in. Okay, so alpha y and then fraction. And it's 9.19 minus 6.364. It's a little bit hard to do looking back and forth. Divide by 2, hit enter. So one side length is 1.413, and that's a little one. So we do it again, alpha y, fraction, 9.19 plus 6.364, all over 2, hit enter, and we get 7.77. So we'll do 1.4 and 7.8. And so those are our 2 sides. So you can see that one right there is the 1.4, and then the big triangle is 7.8. So if we were to draw these out, we have the little one, that's the 1.4, and then we have the big one, and that's the 7.8, 6 and 5, 6 and 5. So there's your 2 triangles for that, and we know that B is 40 and 40, it doesn't change. So now how about angle C? Angle C can be 2 different angles. So you can use law of sines, which I recommend, or you can use law of cosines to find them again. So finding C is now your choice. You can do exactly what we did on the previous B here to find angle C. It's the same thing. You're going to plug all this in and do the same stuff using these values. You now have 2 values of A, so you're going to have to do it twice. Or you can go back and use law of sines to find angle C, and then use the ambiguous case. It's your choice, so I'm leaving letter B up to you on how you want to solve it. Thank you.